What is Docker, and why does everyone in DevOps, Kubernetes, and cloud computing keep talking about it? Simple answer. Docker helps developers package applications into containers so those applications can run consistently across different environments. That means fewer, but it worked on my machine moments. And if you've ever worked in IT, you know that sentence has caused more stress than a blinking red server light at 4:59 on a Friday. In this quick bite, we're going to explain Docker in beginner-friendly terms, cover Docker images, containers, Dockerfiles, Docker Hub, and how Docker connects to Kubernetes and the KCNA exam. Welcome to QuickBytes Education. Today's quick bite is all about Docker, explained simply, quickly, and clearly. Let's get started. Docker is a platform used to build, package, share, and run applications using containers. A container is a lightweight, isolated environment that includes an application and the dependencies it needs to run. Those dependencies might include libraries, runtime files, system tools, configuration files, and application code. So instead of saying, "Here is my app, good luck setting up the environment," Docker lets you package the app with what it needs. That makes the application more portable and consistent. For example, you can build a container image on a developer laptop, test it in a lab environment, and run it in production with fewer environment-related surprises. For the KCNA exam, remember this. Docker is commonly used to build and run containers, especially in development and learning environments. Before containers became popular, deploying applications could be messy. One server might have Python version 3.10, another server might have Python version 3.12. One environment might have the right library installed. Another environment might be missing that library completely. And suddenly the application works in development but fails in production. Docker helps solve this by packaging the application and its dependencies together. This gives teams a repeatable way to build, test, and run applications. That is one reason Docker became so important in DevOps, CI/CD pipelines, cloud computing, and cloud-native application delivery. Now let's clear up one of the most important beginner concepts. A Docker image and a Docker container are related, but they are not the same thing. A Docker image is the package template. It contains the application files, dependencies, settings, and instructions needed to run the application. A Docker container is the running instance of that image. Think of it like this. The image is the recipe. The container is the meal. The image is the blueprint. The container is the building. The image is what you create and store. The container is what actually runs. For the exam, keep it simple. Image equals package or template. Container equals running instance. A Dockerfile is a text file that contains instructions for building a Docker image. It tells Docker what base image to start from, what files to copy, what commands to run, what dependencies to install, and what command should start the application. For example, a Dockerfile might say, start with a Python image, copy the application files, install the required packages, expose the application port, run the application. You do not need to memorize every Dockerfile instruction for the KCNA exam, but you should know what a Dockerfile is used for. A Dockerfile is used to build a container image. That is the key point. Once you build a container image, you usually need somewhere to store it. That is where a container registry comes in. A container registry is a place where container images are stored, shared, and pulled from. Docker Hub is Docker's public registry. Teams can also use private registries, especially in business and enterprise environments. Here is the basic workflow. You write a Docker file. You build an image. You push the image to a registry. A server or Kubernetes cluster pulls the image. Then containers run from that image. That build, push, pull, and run flow is very important in cloud-native environments. Now let's connect Docker to Kubernetes. Docker helps you build and run containers. Kubernetes helps orchestrate containers. Orchestration means Kubernetes can deploy containers, scale them, restart them if they fail, connect them over the network, and manage them across a cluster of machines. In Kubernetes, containers run inside pods. A pod is the smallest deployable unit in Kubernetes. So the flow looks like this. Docker can build the container image. The image can be stored in a registry like Docker Hub. Kubernetes can pull that image. Then Kubernetes runs containers from that image inside pods. But here is an important KCNA clarification. Modern Kubernetes does not require Docker Engine as the container runtime. Kubernetes uses runtimes that work with the Container Runtime Interface, or CRI, such as Containerd or CRI-O. So Docker is still very important for learning, building images, and working with containers, but Kubernetes itself commonly uses Containerd or another CRI-compatible runtime underneath. That is where people usually overcomplicate it. The simple version is, Docker is great for building and working with containers. Kubernetes is for managing containers at scale. Docker and Kubernetes are not the same thing. Docker is mainly used to create, package, and run containers. Kubernetes is used to orchestrate containerized applications across multiple nodes. If Docker is like packaging your application into a shipping container, Kubernetes is like the port authority, traffic manager, and logistics system that decides where those containers go and keeps everything moving. Docker handles the container workflow. Kubernetes handles large-scale container management. For the KCNA exam, do not mix those up. Docker is not Kubernetes. Kubernetes is not Docker. They are related tools in the cloud-native ecosystem, but they solve different problems. Docker is important in DevOps because it supports consistency and automation. Developers can build an image once and use that image throughout the software delivery process. That image can be tested in a CI/CD pipeline. It can be scanned for security issues. It can be pushed to a registry. Then it can be deployed to a test, staging, or production environment. This makes software delivery faster and more reliable. Instead of manually configuring servers every time, teams can use container images as repeatable deployment units. That is a major cloud-native idea. Let's clear up a few common mistakes. Mistake number 1, thinking Docker and containers are the same thing. Docker is a platform for working with containers. Containers are the broader technology concept. Mistake number 2, confusing an image with a container. An image is the template. A container is the running instance. Mistake number 3, thinking Kubernetes directly manages Docker containers the same way older versions did. Modern Kubernetes uses CRI-compatible container runtimes, commonly Containerd or CRI-O. Mistake number 4, thinking Docker replaces Kubernetes. Docker helps package and run containers. Kubernetes manages containerized applications across clusters. Mistake number 5, thinking containers are full virtual machines. Containers are lighter than virtual machines because they share the host operating system kernel. For the KCNA exam, remember these key points. Docker is a platform used to build, package, share, and run containers. A container packages an application and its dependencies. A Docker image is the template used to create containers. A Docker container is a running instance of an image. A Dockerfile contains instructions for building an image. A container registry stores and shares images. Docker Hub is a popular public container registry. Kubernetes runs containers inside pods. Kubernetes orchestrates containers across worker nodes. Modern Kubernetes uses CRI-compatible runtimes, such as Containerd or CRI-O. And Docker is important because it helped make containerization easier and more popular for developers, DevOps teams, and cloud-native environments. So what is Docker? Docker is a platform that helps developers build, package, share, and run applications using containers. It helps solve environment problems by packaging applications with their dependencies. Docker images are templates. Docker containers are running instances. Dockerfiles define how images are built. Registries store and share container images, and Kubernetes can use container images to run applications inside pods. In one sentence, Docker makes it easier to package applications into portable containers, while Kubernetes helps manage those containers at scale. Like, subscribe, and keep building your knowledge with QuickBytes Education, one quick byte at a time.